Hi, I'm Sterling Perrin with Omdia, and I'm here at OFC 2026 and talking with Kobe Reshef, with CEO of PacketLight, and we're going to be talking today about some of the key trends we're seeing in the industry and how PacketLight has fits into those trends. Great to talk to you again, Kobe. It's been a while.
Nice to meet you, Sterling.
So PacketLight as a company, you've been around 26 years, which is a long time.
Yeah.
It's no easy achievement. Clearly, you've remained relevant for that time. What do you think is the key to how this company's remained relevant in a competitive industry?
I think our keys is staying very close to the customers, hearing what they need, and developing the products to fit the needs. We look at different vertical markets, from video to encryption to financial institutes, carrier, service provider, utilities, and for each one of them, we put the features or the products which fit their need. We move very fast in order to adapt, and due to the close relations with the customers, we develop the right products very fast without too many hierarchies in the company to produce the product. So we come very fast with the technology that fits the market.
And optical transport focus, we're at an optical conference, so obviously you're focusing on the optical layers, DWDM.
The WDM over the years changed a lot. It started with gigi, 100 gig rates, with chassis for 10 gig only, and now we got to 8 tera in 1 RU. So evolution is enormous. The technology there, I think it's the most advanced market in terms of technology shifts.
Certainly in 26 years, you've tracked that entire curve. There's different applications in optics, as there have been, but right now, I think it's obvious the focus of the industry is very much on AI. The transport network has a role to play, certainly, in AI. Can you talk to how AI is impacting and transforming the transport network?
So AI, in order to operate, needs a lot of transport, a lot of capacity for the inference phase, for the learning phase. It's not just an issue of the amount of traffic, it's the latency and jitter of the traffic, because you don't want your CPU to stand idle and not process something. So WDM and OTN are predictable layers. You know the latency, you know the data will not be switched or out and come in latency, and the GPU will stand idle without processing the data. So driving the capacity, the rate of the optical signal, the amount of data we can pack in a fiber, and the how compact it gets in order to fit this amount of capacity into the same rack with the same power that, which is quite a challenge as well.
So there's, the terms that are used are scale up, scale out, and scale across, which is essentially, the DCI for an AI now, where you're fitting in to that scale across.
We are transporting the data from one side to the other side fast, predictably, low latency, low jitter.
Yeah.
And we can go and we utilize the fiber to the most. C-band, L-band, all the technology, flexibly, to enable us to move very fast with the optical signal bandwidth that we meet. So we meet 10 gig, then 100, 200, 400, 800, and we are going to meet 1.6 tera. So everything is ready and adapted for it now.
Okay, so you have, and let me kind of take the 800 gig, I'll put it to the side for now, because I want to dig into coherent 800 gig in a minute, but you did mention OTN, and so, one of the things we see within the data center is of course, Ethernet versus InfiniBand for the very, very short reaches, and then you kind of have a concept of Ethernet everywhere in the data center, and then, to a degree outside the data center, but for these AI applications, you're saying there's a role for an OTN transport network for the data center interconnect.
The role for the OTN transport is for the distances. If you want to build over a longer distances, if you want to have the FEC, forward error correction, you want to pass few amplifiers and you want the entire network to work, the OTN is a must-have layer going over the transport. As I mentioned also, the jitter and latency is predictable.
With OTN?
With OTN.
Okay.
And then you can deliver something predictable in the AI, and it's specifically important for the AI, for the GPU not to stay idle.
Right. So what sort of distances then does the OTN become most relevant, you think?
So I would say the OTN above 80 kilometers or 100 kilometers, when you need to pass few amplifiers, you need to start to use Raman amplifiers due to the OSNR. Then you need to have the FAC layer to fix the errors which are created over the link, and to have a reliable link without any errors.
Okay. And you're doing this
As part
today?
of,
You have
we
customers
have
that
it today, and we have 2,000, 3,000 terrestrial networks. And if you go to the subsea, there are thousands of kilometers of subsea. With amplification along the path, they must have OTN.
Of course.
Ethernet as Ethernet natively cannot pass this
Of course,
path.
of course. One of the other things we also track is openness of networks. Optics historically has not been very open. The hyperscalers have certainly driven a lot of requirements for openness.
Yeah.
Where, how is AI affecting requirements for openness and interoperability? More, less?
So
No?
if you go back like 3-4 years ago, when there was 100 gig and 200 gig, there were no standards. The 400 gig put a sign for standards. So there were the ZR, ZR Plus, and Open ROADM. All the DSP vendors across the industry match this standard. So you can connect a DSP from different vendors or optics from different vendors, and they can work opposite each other. There is interoperability. It wasn't before in the industry. So that's one thing. The second thing is also on the client side, on the interfaces, all the standards are being really kept, and any optics from any vendor can interface with any optics from any other vendor. So that makes the network much more robust. You can have second sources, you can have multiple solutions, and you can pick the best in terms of pricing, power, performance, or whatever is your concern.
Right. So are you exclusively pluggable optics for your products?
We use the standard pluggable optics. In the past, we used bulky modules, which were unique and not standard ones,
Right.
because that was the only choice that we can use. After we saw the evolution of the pluggable modules, we use only pluggable modules in our system, and only one which are adhere to the standard. If they don't adhere to the standard, we don't use them.
Okay.
Because the technology moving so fast, if you're using something which is not standard, after 1 year, 2 years, it will be out of the market. You cannot support a customer, and you cannot leave a customer without support after 2 years, and because you used unstandard optics.
Agreed. Let's dig into the 100 gig, the 800 gig a bit. Coherent 800G, a big topic at this conference, and certainly for the year as well. Forecasts, including from Omdia, for very significant demand or 800 gig. Are you seeing 800 gig demand today for PacketLight?
So we start to see the 800 gig from the customers, and the main reason is the cost. Again, cost per bit, power per bit, which drives the innovation and the bandwidth and answers the bandwidth demands much better. So if you take 800 gig module today, it costs 30% less than 2 modules of 400 gig. So for customers building a greenfield network, for sure they will go and migrate to 400 gig if they need the capacity, and especially the AI customers and the high bandwidth demanding customers. And I think that it's the same as happened in the 100 gig to 200 gig phase, when 200 gig beat the 100 gig, and then 400 gig costs today the same as 200 gig module, and 800 gig in a year from now will cost the same as 400 gig module.
So you think the price will continue to come down?
So the price will force the movement. Power consumption is less. You can put more density into one RU. So more capacity, less power, and less cost. So this will, there is no choice for the market but to run after these rates and pace, and 800 gig is the next step.
And do you see that demand even today among
we start to
customers?
see the demand today for the early adapters. The only issue with the 800 gig that we see is not an easy migration like it was from 100 to 200 to 400,
Yes.
which can fit the same spectrum or the same shape of spectrum of 100 gig spacing. 800 gig need 150 gigahertz spacing. So this is where flex grid or different filters need to be used. So brownfield networks, sometimes it takes more effort to adapt to 800 gig. Greenfield network, it's obvious.
Right.
So this is a bit stopping the momentum of 800 gig, not to be as fast as it was with the previous
The
generation.
line system needs to be upgraded to fit
You
The
need
the
to
800.
upgrade some of your infrastructure, not just the optical modules, transponders, or pluggable modules.
Right.
It's a bit more than that.
That's a good point. What about different customer segments? We certainly hear a lot about the hyperscalers are driving, but they're not the only types of buyers or service providers. There's the neo cloud, neo scalers. There's large enterprise. There's telco.
There are government projects or
Government.
government AI, sovereign AI, which
Right.
they build their infrastructure, cloud providers. We see a lot of submarine traffic due to the AI and due to the amount of capacity, and there is a need to connect from the submarine landing point to the data center. So a lot of networks are being built from the submarine cable lines, landing points, to the different data center, Equinix, Global Switch, and others, in order to distribute the data between
So
them.
these are the terrestrial networks. that
Terrestrial
connect out.
networks, which need to complete the subsea fibers or
Yep.
connect to them. And this is where we see a large growth. Neo cloud, as you mentioned, there are additional competitors to all the hyperscales which are trying to compete with them, and they need also a lot of bandwidth. All the e-commerce companies which are selling over the internet, they need a lot of amount of bandwidth, and they are also adding AI, and they need more bandwidth.
Right,
And
right.
that's one of the things they see growing
So
as well.
you're seeing a pretty broad stretch of demand across segments for
across
800
a lot of
gig.
segments, from government to carriers that need to serve this bandwidth growth over the network. And we see also a lot of need for encryption on the links. The links need to be secured. You don't want in an AI environment that someone will alter or change your data in the middle. So there are a lot of risk in that, because then all your model will not work, all your learning and so on. So it's becoming even more crucial in AI environment to have encryption, to have security. The data you process, the data you store, your learning, everything needs to be very, very secured.
Interesting, yeah. So let's get into that. I know you're even before the AI boom, your company has focused quite a bit on layer one encryption. Maybe you just address what you're seeing for customer requirements. You started with AI, but maybe even more broadly.
So everything started with compliance to regulation, to government regulation, especially in Europe and other territories like US. There are healthcare requirements, financial requirements that you need to encrypt the data. If you have personal records of a person, or your health condition, or credit card company, or credit card details,
Yep.
then you need to secure them. Also, when you connect between two, you need to back them, and you need to back them in a faraway place. So you need to connect between two remote data centers. Then you have a fiber between them, and the fiber is exposed. If you bend a fiber and 1% of the data, you can extract all the data from the fiber. So everything needs to be encrypted to ensure the security. It's coming for complying to regulations. And then all the market, and there are standards like FIPS and common criteria, which make sure that you comply to the regulations of the healthcare and the financial market and government entities and so on, tax authorities. And then we added AS 256 layer one encryption. We certified for FIPS and common criteria. And this is something that our customers need. And now there is an additional evolvement in the last 3-4 years, the quantum key distribution. So even the Diffie-Hellman key exchange, which is used today, which is considered still very secure because there are no quantum computer yet, people are afraid that the data will be recorded today, and then you can de-encrypt it when the quantum computers will be in the
Harvest
market.
now, decrypt later.
Correct,
concept.
exactly.
So yeah, I mean, I certainly read about that a lot. I have talked to some customers, companies about that. You're actively, when you meet with companies, customers, they're aware of this issue and bring it
They
up
are
to you?
aware. It depends on the level and the different countries and the approach. Some go to QKD solution, quantum key distribution,
Right.
and some go to PQC solution, which is just changing the algorithm but passing the keys over the internet. Each one of them has its own cons and pros. We can interface. We don't care. Whatever the customer wants, and we can connect to two systems in parallel even.
Okay.
And get the keys from quantum and get the keys from PQC, post-quantum encryption servers, and then encrypt the data using both. So it's over security, over security, over security.
Right, and this is an increase. You're seeing this as increasing and will
We see
only
it
continue.
as an increasing, and the moment. So the innovation of QKD started about 10, 12 years ago, even more. the market didn't adapt it because of the cost and the complexity in having an additional fiber. But as we go along, the ecosystem there evolves. There is not one vendor, but there are like 10 vendors doing QKD and PQC, more even. So the ecosystem is there, and I think the market demand, and it will grow, and we are ready for it. And any of our system can connect to these devices.
Something we're following quite a bit. Maybe maybe one last question on that before we close out, because these the quantum and even the PQC, they're separate systems from you. You're a transport vendor, transport network. What do you need to do as a transport vendor to be part of that quantum safe solution? Like what should a customer be looking for?
So the customer must have in his layer 1 optical encrypted DWDM, he must have the AES machine. He must have quantum random generators on board, on card, that can be used. So in case we lose the communication to the QKD devices, still the data is encrypted. And we need the standard ETSI interface to these third-party servers in order to get the keys in both ends. And you need, of course, to certify your WDM, because without certification, it doesn't prove that you actually encrypt.
That's a very good point. So you've gone through the certifications.
It's a tedious process, takes a lot of time, a lot of money, but we do it time after time for each of the products because it's essential.
Great. Obviously a lot going on with PacketLight. Always good to catch up with you, Kobe.
Thank you. It was a pleasure meeting you.
Yeah, good seeing you.
Thank you.